Hey everyone, this is Luke from Cadus Maths, and this video is an introduction to vectors. We use vectors to describe the motion of moving objects, but we also use vectors as a way to solve a system of linear equations. Essentially, vectors have a magnitude and direction. They are often used in physics and maths, and here are some examples of vectors. There are many more examples of vectors. However, all vectors rely on two number quantities to describe them. In the case of velocity, it's meters per second. For acceleration, it's meters per second squared. One way of representing vectors is by using the real plane, geometrically. Let's now begin by drawing two perpendicular axes. Let's say there's a dot that starts at 0, 0, the origin, and moves 4 units to the right, and then 4 units up. The coordinates are 4, 4. The simplest way to describe a vector is by drawing an arrow, where the arrowhead points to the direction and the length of the arrow represents the magnitude. Vectors can also be represented by a matrix column, where the first entry represents the horizontal displacement and the second entry represents the vertical displacement. Let's go back to our example of the ordered pair 4, 4. Based on this column matrix, we can say that the first entry 4 means 4 to the right, and the second entry means 4 up. And there we can draw our vector arrow to symbolize the magnitude and direction of this particular dot. What about the column vector -3, 2? This first entry has a negative number. All that means is it's going to travel or have a displacement of 3 units in the negative direction of the horizontal, or in this case, x-axis. Then it will go 2 up, because 2 is the second entry. Vector arrow starts at the origin and extends to the ordered pair -3 and 2. So remember, vectors can be represented in a variety of different ways. Let's now return to vectors as arrows. We call the length of the arrow the magnitude. And we call the beginning of this vector the tail, which in maths and physics denote with capital letter A, and the ending of the vector, which ends at the arrowhead tip or head, letter B. To represent vectors symbolically, we often combine these letters and put an arrow on top to say that it's a vector, vector A to B. We often also use the lowercase letters to symbolize vectors as well when they have a small wavy symbol called a tittle. Vectors are the same when they have the following properties. That is, that they have the same length or magnitude, they point in the same direction, and are parallel to each other. Let's see which vector arrows are the same. These two are the same. These two vectors are also the same. However, these two are not the same because they are not pointing in the same direction, while the other previous two were. How about these two vectors? Yes, they are the same vector because although they are in different spaces, they have the same magnitude, they're pointing the same direction, and they are parallel to each other. When looking at vectors as column matrices, it's also important to remember that they have to have the same entries, top and bottom, for them to be the same or equal. Let's look at this example of the two column matrices 1 and 3 and 3 and 1. So the blue matrix vector 1, 3 goes 1 to the right and 3 up, while the orange vector column 3, 1 goes 3 to the right and 1 up. Yes, they have the same magnitude, but they are not parallel and they are not pointing in the same direction. So therefore, they are not the same vector. A very important property of vectors is actually vector addition. Let's denote two vectors, vector D and E, and let's add them together. We put the tail end of vector E on the tip of vector D, and then we join them together. So what we get is vector F, which represents the summation of vectors D and E. Let's see if there's a difference if we now instead add vector D to vector E. So we do the same thing. We're going to move vector D, the tail of it, to the tip of vector E, and we see that it adds to make vector F, which is the summation of vector E and vector D. So what we notice algebraically is vector E plus vector D is the same as vector D plus vector E. This method is known as the tip-to-tail method. Another method of adding vectors is called the parallelogram method, where we join the vectors to create a parallelogram, and by adding them is simply the fourth corner of our parallelogram. Let's see this geometrically. There be two vectors, a blue one and a magenta, and they all begin at the origin. Let's now create a parallelogram, and from this origin we're going to a yellow vector which represents the addition of the blue and magenta vectors. Let's go and try the tip to tail method. We're going to put the magenta tail to the tip of the blue vector, and we get the same result. Let's do another example, but this time we're going to use the vector columns. Here we have a green vector, which is -3, 0, a pink vector, which is 1, 0. If we use the parallelogram method, we would create a parallelogram, and the fourth vertex or corner should be the summation, which is -0, represented by the yellow vector. We can add column vectors together, entry by entry. Let's do an example with the vector columns 4 and 2 added together with the column vector 2 and 4. If we add the entries respectively, we should get 6 and 6, which is the addition of those two vectors. So in general, when we add vector columns, we assume that they are real numbers and obey the algebraic rules of addition. Let's do one more example of the head-to-tail method with two vector columns, 1, 2, plus 2 and 1. As these have two entries, we assume that this is the real plane, or R2. We're going to add the tail of the purple vector to the tip of the orange vector and form a triangle, which is the tip-to-tail method, and the solution is a new vector, 3, 3. Let's relook at the parallelogram method. So we redraw our two vectors, the orange and purple. We form a parallelogram, and the new vector, which is the summation of these orange and purple, is the fourth vertex of this parallelogram. Whether you like to use the tip-to-tail method or parallelogram method is based on personal preference and even circumstance. Hope you enjoyed the video. I'll see you in the next one.